So how electron is configured within an atom? So this is very important. We have learned how an atom, based on the number of electrons, how big the atom is going to define what is the quantum number that belongs to the electron. How can we configure the electron inside the atom? Every element has their own atom. So each atom has different number of electrons, right? So how be able to determine how many electrons in an atom? We know particular element, we have the atomic number, the number of proton. So for a neutral atom, electron is equal to the number of proton. By knowing this number of electrons, we should be able to configure the electron within the atom. Say for example, for an element having the Z equal to 10. So definitely it also has 10 electrons. So how this 10 electron is distributed inside the atom? Okay. In order to decide the configuration of electron for an atom, we have to follow three principles. One is Aufbau principle, two is Hund's rule, and third is Pauli exclusion principle. For the Aufbau principle, the electron need to fill up the lower energy orbital first before fill up the higher energy orbital. Okay. Meanwhile, Hund's rule mentioned that two or more orbitals available at the same energy, the electron need to go into each until all of them are half full. Say for example here, we have the quantum number 1, we have quantum number 2. For the principal quantum number 1, we have 1s orbital, right? So for the energy level 2, shell level 2, we have 2 orbitals, which is 2s orbital and 2p orbital. We know that for s orbital, it has 1 state of energy. However, for the 2p, it has 3 energy states. So following the Hund's rule, whenever we have electron in the atom, as it fills up the lower energy first, which is filling up 1s orbital, okay, followed by 2s orbital, and then followed by 2p orbital, followed by 3s orbital. But when it actually is trying to fill up the 2p, it has 3 states of energy, right? So the electron will fill up the same spin first, half full, then only going to fill up the another half of the state of energy for 2p orbital. Then only when these states are full, it's followed by 3s orbital. So that is how you're going to configure the electron inside an atom. So as mentioned earlier, no two electrons can be identified by the same set of quantum numbers because each atom has plus half and negative half spin. Okay. For example, if you are given an element which is iron, okay, and then when you refer to the periodic table, you see that the atomic number for the iron is 26. So it means that the proton is equal to 26, and you know that the electron for the neutral ferrum atom is also equal to 26. So how to configure this 26 electron in the ferrum atom? Okay, as you know earlier, in order to do that, we have to follow this method of arrangement. Okay, this method of arrangement. You write 1s, 2s, 3s, 4s up to the 8s, following the 2p, 3p, 4p, and then from that, you're going to draw the arrow. So following the arrow, you will know which energy level that you have to fill up first, okay, before the other. Some of the quantum number or quantum energy level, say for example for 4s having lower energy level compared to 3d. So by using this method of arrangement, you will know which energy level that you need to fill up first. Okay, so back to the iron with the 26 electrons. So definitely from that method of arrangement, you know you have the 1s2, which is 1 is equal to the quantum number principal as the subshell or the orbital quantum number and the number of electrons inside the orbital. So you have 2 here, okay? And then fill up 2s, another 2 electrons. So total up 4, right? So another 6 goes into 2p orbitals, 2 into 3s, 6 into 3p. And then you know for the 4s is fill up first before 3d. So fill up 4s, 2 electrons, and then another 6 electron is going to fill up the 3d orbital, okay? So if you total up 2 plus 2 plus 6 equal to 10, plus 2, 12, another 6 is 10, 18, 24, 26, okay? So if you want to represent this electronic configuration into a complete wave mechanical model for theorem, it is going to be something like this. Because you have the 1s orbital, only one state of energy, each electron having half spin plus half spin and the negative half spin. Okay, so all the arrow is representing each of the electrons. So you see this is the complete wave mechanical model for theorem. So this is how you can determine the electro configuration of an element. For this, you can see that the one which is 1s having the lowest energy value compared to the higher energy level, which is the 3D, okay? Because this is due to the distance from the nucleus. So let us do a simple exercise. The question states the electronic configuration of silicon atom. This is the answer. So what should we do when we get this kind of question? One is, definitely you need to know what is the number of electrons in this silicon atom. So where can you get this information? Definitely you have to refer the periodic table. So by referring the periodic table, you will be able to know the atomic number, which the atomic number will give you the number of protons. And if actually the question haven't stated that the silicon is in terms of ions, so it is normally considered as the neutral atom, where the proton is equal to electron. Then after that, by knowing the electron number inside the atom, you need to draw the method of arrangement, because you need to know based on the above principle as well as the Hans rule that you need to fill up the energy level which is at lower energy first, then followed by higher energy level in order to locate the electron based on the energy state. Okay, so then only you can write the electronic configuration for that particular atom. Okay, so for this exercise, we have to refer the periodic table for silicon. So as here we refer the periodic table, you will find the silicon having the Z value equal to 14. Okay, so the Z value equal to 14 means that the number of electrons inside the silicon is 14. So next, you have to draw the method of arrangement. So it's simple. First, you write the 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4s. So you will draw the arrow in order for you to identify which energy level has the lowest energy level for you to locate the electron based on the above principle. Okay, so you know the number of electrons is equal to 14. So the first energy level, which is the lowest, is 1s orbital. Okay, you can fit in 2 electrons in the 1s orbital, followed by 2s, another 2 electrons, 2p, since you know the orbital p has 3 energy states, so you can locate 6 electrons inside the 2p orbital. So now as you total up, 2 plus 2 plus 6 is already 10, right? So you left with another 4 electrons. So after the 2p, followed after that is the 3s. So 3s, another 2, left with another 2 electrons. So it goes to 3p, another 2 electrons. So you total up, 2 plus 2 plus 6 plus 2 plus 2 is equal to 14. So you can write this 1s2, 2s2, 2p6, 3s2, 3p2, or in short, because this is the electronic configuration for neon, okay, because neon has Z equal to 10. So you can write as neon electron configuration 3s2 3p2. So this is the answer for this particular question. But bear in mind, if your question asking you for ion instead of atom, so you have to identify whether the ion is negative ion or positive ion. So when an atom receiving other electron, it will become negative ion, but if it donates electron, it will become positive ion. So by being negative ion, it means that the atom having the increment in the number of electron based on the number of charges, as well as if the ion is positive, it means experience reduction in the electron number based on the charge of the ion. So even most of the electron configuration for atoms or ions can be solved using the method of arrangement, but not all can use that particular approach because there are lists of anomalous electronic configuration here. You can refer that this material having anomalous electronic configuration, which is not following the method of arrangement. But you don't have to worry, you don't have to memorize it, okay? This is only the additional information for you.